So again, thank you all for coming today. So for the first research seminar of autumn 2016-2017. So today I'll be talking about Internet of Things. Internet of Things and beyond. I put the and beyond there because Internet of Things is a small concept in a very big variety of applications. So I'm going to focus on what is Internet of Things for those who don't know what Internet of Things is, and then move on to specific research domains that are hot and people are working on, and finally talk about what I'm doing personally, what grants I have funded in this area, and how hopefully I can partner with many of you. So let me move on. So what is Internet of Things? So Internet of Things, if I were to define it, again, it's a network of devices typically communicating with each other in a very simple terminology. And these devices could be computers. That's the old quote-unquote computer network. Obviously, it has evolved to become network of sensors, network of microprocessors, and so on. So anything that we could connect together, typically wireless, we end up calling them Internet of Things. Why Internet of Things? Because eventually they are connected over the internet. Maybe not the same protocols, but typical protocols that were used before can be used as well. So Internet of Things, or as many people call them, Internet of Everything, this is the way the future of the internet would be. So if you look at different terminologies, so different people or different research groups call it differently in different domains. So some people call it machine-to-machine, M2M. That's a subset or maybe even a superset of Internet of Things. Cisco decided to call it Internet of Everything. So you have the Internet of Things, you have the Internet of Everything, you have also the world-size web, so it's like the WWW, the World Wide Web that we know of. Now people refer to them as, again, as I said, world-size web. And finally, Skynet. I put this out there for those who watch movies. You kind of obviously know what I'm referring to, Terminator movies. So the concept of Internet of Things is not something new. It has been there for ages, 20, 30, 40 years ago. And the media kind of perceived it as something like this, what they envisioned the Internet of Things to be. Again, it's Skynet, if you know Terminator movies. So the idea is robots will take over, devices will communicate with each other, again, to achieve a specific task. So Internet of Things is a very big research domain, and it's being funded big time in the UAE and around us as well. Like an example, in Qatar now we have an innovation fund for Internet of Things. We have one here as well in the UAE, Internet of Things in the logistics business. So you have all these funds for and Qatar World Cup as well. They have an innovation fund called Internet of Things for the World Cup 2020, the one coming, or 2022. So Internet of Things is a big topic. Obviously it's everywhere. Again, I could go from the small RFID tags to the NFC wristbands that we wear in Wacky and amusement parks or Disneyland, to the more scalable stuff like, again, IR sensors connected to barcode readers and so on and so forth. So ideally, again, to look at technologies, as I said, I will just give you a quick intro on Internet of Things and then focus on the research part that I'm working on. So you can see we have wearable technology is a very hot topic. Again, has been there for quite a bit, 10, 15 years ago. Healthcare industries and obviously smart appliances. So the word smart is going to be something I'm going to talk about in a second. So smart is related to anything I put smart next to, I kind of refer to Internet of Things. Again, from smart buildings to smart houses to smart cars to smart infrastructures. So ideally, this is a very nice, if somebody's interested in Internet of Things research, in my opinion, maybe this is the most important slide. So this kind of summarizes everything you need to know about the different sectors of Internet of Things. I'm going to go over it really quick because, again, my target is to finish in 15 minutes, as I mentioned. So you have buildings, again, hence smart buildings is a very big topic now, from the design of the building itself to include embedded sensors in the concrete, in the structure of the building, as well as sensors within the building itself to communicate with each other. So you have smart energy, again, solutions, from sustainable energy solutions, again, consumer appliances, that's a big topic when it comes to Internet of Things. You have healthcare, as I mentioned, industrial applications, transportation is a big thing. I personally have many projects in that domain. You have retail as well. We have some projects in this. So if you want to look at these domains, we are involved in at least 3 or 4 of these sub-sectors, if you want to call them. We call them the service sectors. Within each sector, we have, again, some groups, and finally locations and devices. So IoT market as of 2016, I try to get the numbers as much as I can. That's 16 billion again IoT units. That's expected to grow to about 30 billion by 2020. So the graph is kind of exponential. You can see it's very big. Obviously, revenue-wise, it's making tons of money in different sectors. And one of the big questions I'm going to talk about in a second, maybe the faculty of business will be interested in this, is what is the business model? How do I make money out of this? Okay, so the idea is we can have a business canvas and do a lot of things. When it comes to Internet of Things, it's very kind of volatile. We don't know how to measure the business revenue stream and the profit as well. So that's one of the research topics that I have one of my students working on as well. So opportunities-wise, again, obviously you're talking about billions or trillions of sensors and devices having addresses communicating with each other, which means entire new ways of communication, which means a lot of research opportunities to come up with the next protocol for communication. Obviously, it means comprehensive perception because we're talking about heterogeneous. They're not homogeneous anymore. So I have sensors that are using a specific kind of protocol, communicating with other sensors that are using some kind of protocol. So this heterogeneous architecture obviously implies we need to figure out a way to do this, and they haven't done that yet. So intelligent processing maybe is the biggest question that I think many of my colleagues are working on, is if I get all this data, again from the Google, from the Facebooks and so on, hence quote unquote the big data, what do we do with it? One, how do we get them? Two, how do we mine them? Three, data mining. And finally, how do I analyze them? And obviously big data has been a very interesting topic for many researchers around us, but when you tie it to Internet of Things, it becomes more interesting. So one example is, I'll talk about that project in a second, is applying it in a university or in a school. You know, like I work in schools a lot. So in a school, you have all these sensors monitoring where students are at specific times. And for example, if I have data that says 80% of the students are next to the cafeteria, and I could look at their performance, I could make some kind of correlation, say the more they stay in the cafeteria, the better they do in their exams. So we couldn't do that before. Now we can, because all these sensors are spread around the campus, we can figure out all this logic. So ideally, again, so what's the big deal? Again, yet another computer. We've had computer networks for quite more than 40, 50 years. So what's the big deal? The big deal is scalability. So again, we're talking about now billions, as I said, or more billions of connected devices together. So scalability implies more application potentials. So you can apply it almost anywhere because it could be this big or this big. At the same time, it means vulnerability, right? Obviously, security guys who work in security know that one of the biggest research topics is how can I make it secure? How can I make sure it's not hackable? Or look at the existing security protocols and obviously apply them in Internet of Things. So again, the notion of smart, as I implied 5 minutes ago, so smart is something we're using a lot. Like when the iPhone came, everything was iPhone, iCable, iDoor, and so on. Smart is something very common now. Everything we do research, smart cars, smart homes, smart cities. If you look at the UAE vision by 2020 is to have a smart city, quote unquote. So what is smart? This is for us to define. So smart could be as basic as having e-applications or online applications, or obviously having a connected city from the schools, campuses, and so on. So long story short, obviously we have a lot of communities, like anything else, like we have for internet communities working on internet from the early days. The same thing with Internet of Things. You have the IoT, you have mobile computing, you have the pervasive computing, or the ubiquitous computing. They use these two words together. Wireless sensor network, this is a terminology that has been there for quite a bit. My PhD in 2002 was on wireless sensor network. I mean, that was, what, 14, 15 years ago. So that was on the USN. So obviously it has evolved to become Internet of Things as we speak of it today. Obviously, recently we refer to them as CPS, cyber physical systems. Why cyber physical? Because they're attempting to combine the cyber or the internet world with the physical world. So instead of me Googling data, I'm not Googling data anymore, I'm Googling physical entities. So I could Google KAMAL, I could Google a guy, a physical person. I could Google a table, because all of them are connected, all of them have IP addresses, obviously. So, underlying technologies, we talk about real-time computing, machine learning, security, privacy, obviously signal processing, big data for database, data mining, and so on. If you look at Internet of Things, that's why I wanted to start this research seminar series by talking about this topic, is because it kind of spans over many different domains. So the electrical engineering, computer science, computer engineering, and obviously business as I applied. So this is a very nice topic that many people could partner together in a very unique concept or unique application. So again, now it comes to research questions. So I put here some research questions that the research community is working on as we speak. And these are things to keep in mind. If you're interested in any, we could take it further beyond this seminar. So obviously the first question is, how do I name them? How do I authenticate them? Because you cannot simply name them the same way you name computers because of the scalability. Again, obviously IP version 6 came a while back. Is it enough to use with these kind of devices? What kind of protocols? I'm not going to go too technical, but what kind of protocols we need? And one example is, you can see there, is a low band. So you have what applications are possible. This is a big question. I mean, there are many innovative applications being funded now that nobody have thought about before. How can I use this Internet of Things in different contexts? And finally, again, what do I do with all this data? So I get all this data, so what do I do with them? So that's the next stage. And this is, again, another big question. One is, how do I get them using the Internet of Things? Second question is, what do I do with them? Again, this is what Facebook, Google, and all these guys are trying to answer as we speak. Obviously, we talk about data mining, data warehousing, and all these concepts. So, our research project, now it comes to what I do. So this introduction kind of led to where I am now. So a lot of projects I'm working on as we speak, it's a bit too much in my opinion. Maybe I need to slow down and maybe partner with many of you to help me out. But many of these projects are either funded, I have funding for, either locally or external funds, or have been published. Many of these I published in the journals already, and I'm working on scaling them up. So I'm going to go flip over these real quick, and I'll focus on some specific ones. So smart cities, architecture. So again, I've worked on many technologies and protocols in order to design a city that is smart enough to allow electric cars to charge themselves while driving. So I'm going to talk about this in a second. So we have smart education system. Again, I've worked on software technology, including mobile apps, wristbands, NFC wristbands, Internet of Things, augmented reality education applications. All this in the smart educational field. Talk about smart buildings, augmented reality. Drone technology is something I work on a lot. I have some projects ongoing and some others that are looking for funding. Let me go and talk about them one by one, focus on some specific one. One of the big projects I worked on, this was funded initially by Emirates Foundation, about 300,000 dirhams. Then it got funded by NRF, about 200,000 as well. In different contexts. One was about sensors, charging, and the other was about charging cars. So the vision of this, which is a bit mathematically complicated, we kind of derived equations in order to look at the possibility of multi-hop energy transfer. So in simple terms, for those who don't know much about maybe networking, so we have single hop, we have multi-hop. Single hop meaning I have a router, I'm connecting to it, one hop. Multi-hop, no, I connect to a device that's basically a middle person between me and the other communicating device. So in this case, I'm not sending data, I'm sending energy. That's the first thing. Second thing is multi-hop energy transfer. So cars can send energy to each other. So if I need energy, I'm an electric car, you're an electric car, I will send you energy. Again, for a specific business model. So obviously I can send you energy when you need it. Or I could get energy from the infrastructure itself. So we kind of analyze these technologies. The next stage, as we speak now, is we want to build the actual electric car. We're building a prototype that could drive, and that car would be able to charge wirelessly and charge other cars wirelessly. This was a big project, has been going on for almost 2 years. And now, as I said, we are at the stage to actually make it. Another project is the solar drones here. I got funds from this as well. And the idea here is to build drones that could basically clean solar panels, because if you know a bit about solar panels, if they have dirt on them, the efficiency drastically goes down. So and now what they do is manual cleaning. So the guys will go up and clean them one by one. They have a robotic platform, but these are typically standing within the building itself. So the idea here is to build a team of drones that will fly over the panels, detect the dirt, go down, clean them, and then go up again and do patrolling. So when the battery runs out, they park, the other guy goes up, and so on and so forth. So you have some drones have the ability to detect the dirt using image vision and so on, and some other drones are in charge of looking not only at dirt, maybe damaged panels, because you have birds that will land on them, and so on and so forth. So this whole project is about sustainable energy solutions using drones. Drone herd, again, along the same line, this is a very cool project. I applied this last year for Drones for Good, this $1 million project in the country. We kind of worked on it a little bit more last year. So the idea, again, drone technology, and this is very cool. So the idea is to have these drones fly over where camels are. We all know what camels are very valuable in this part of the world, they're very expensive. Unfortunately, camels damage the environment. Camels might have accidents and collisions and so on. So the idea of these drones is to figure out where the camels are and divert them from going to the streets by using ultrasound and some kind of sensor technology on board. So they kind of deviate them away from the roads. They know where the path is before they get there. Now what they have all these fences that kind of prevent the camels from crossing over. But the bad news is camels get stuck in these fences. They're very expensive, so that's not a very good solution. It should be a way we could deviate them away before they get to the gates. So this is a project that kind of proposed this. Again, using the same technology, drone technology. In this case, they don't clean, instead they deviate them away. We have smart rotating solar panels. That was a collaboration between me and Dr. KAMAL. Now we have a student as well working on this. So the idea is, in simple terms, solar panels could be static like this, but they could be rotating horizontally or vertically. So the idea is, we studied here the concept of having something called smart rotating buildings. So the building itself is rotating, and every floor is rotating as well. So if we do that, we're analyzing different topologies, because you have many combinations. We have static in the rooftop, on the sides I could have vertical panels, and so on and so forth. So we're analyzing all these combinations to find kind of the most efficient. Obviously, if the building is rotating, it's costing us energy. To generate energy, we're kind of losing energy. So we're analyzing the trade-off between rotational systems as well as solar capture. Okay. Another project is gamification parenting. This is a project we applied for a Qatar Foundation. It's called the USRA grant. So the idea was here is to use gamification. And you can see I just drew this for you. This is from Gartner. So one of the hottest topic in research areas as we speak in computer engineering is gamification. It's actually at the peak, if you see here. So gamification is a very new concept. Is how can I use game elements in games and apply them in real world scenarios. And this example is to develop a mobile app to allow parents or moms and dads to actually control technology use with their kids. Ironically, I'm using technology to control technology, but it's all fun because it's gamified. So you get points, so the dad will get points, so the kid will get the grades, and the parent will get the points. So it's kind of a reciprocal grading. So that was, the idea here is not the application itself, it's to create this knowledge base. Knowledge base, again, back to big data. So I have a lot of data now, how parents are talking to their kids, how kids are talking to their parents, what they're doing, how many times they're using the tablets per day, and so on and so forth. So the big question is, what do I do with this data? Educational technologies as well. This is a project we applied for ESDF in Wollongong, Australia, $30,000–$40,000. So the idea here was, this is something I worked on 2 years ago. I published in a journal on this. The idea is, you know, the wireless voting systems that we have, active votes. So you could vote, the students can vote. So that has been there for quite a bit. This project, for the first time, proposes the concept of something called dynamic lecture notes. So my presentation is dynamic. So when I change the slide, it depends on the feedback I got from the students from the question before. If I ask a question about some concept, if 80% got it wrong, automatically if I move to the next slide, it would be another example similar to it. I don't have to minimize and open the question like we do them today. So this is a very unique concept. One, you not show the students that you're changing a lot. The presentation by itself is kind of dynamically changing based on the feedback we get in real time from the students on their knowledge of specific concepts. So we did research on this, initial prototype, and the funding was to actually apply it in Wollongong in Dubai. That was the concept behind this. Touch marketing is another project I'm working on. I'm almost done. This is a nice project. The idea here is we got these sensors, we call them non-conductive touch interface. So these sensors, you could put them behind wood, like a wood which is non-conductive, and still conduct, which was kind of interesting. So we applied it, me and Dr. Prakash, for fact of business, on a board where you kind of put, like, let's say, a shirt behind it. We see if the customer touches the shirt, would that increase his probability of buying the shirt? If you kind of could feel it, this haptic touch. Because now, as it is, you can see a commercial on TV, you can see billboards, or you can see the shirt itself. What we did, we had a billboard. On the billboard itself, we had these items that you could touch and feel. When you touch them, you will get the video that will interact with you. So we combine different kind of perception, as you can see, the haptics, the taste, the vision, and obviously the smell as well. So we combine all these together and see what is the effect of the probability of buying the product. And this is again under an A journal in marketing. This is a bit away from my area, but it's a combination of Internet of Things and marketing. So these are other research projects, just to finish up. So these are projects that my students are working on. These are thesis students, and I'm supervising them. I have one PhD here that I think is almost done. I think she's going to present her dissertation very soon. That was about social networking and user perception of quality. So if healthcare providers have a Facebook account, how would that affect the perception of quality on the patients? So do I think this hospital is a better hospital because it has a better Facebook page, you know? Does that mean anything? So that's her whole PhD. She actually analyzed all the healthcare providers in the country and kind of found some kind of correlation with this. And all the others, like I work a lot in project management. Innovation is something, again, it's a very passionate topic of mine. So disruptive innovation management, we have a paper on this as well, master thesis student. So we have a lot of work in these areas. So all in all, just to finish up, the idea is Internet of Things is everywhere. As you can see, I gave you sample examples of smart cities, smart education systems, all using the same concept, which is Internet of Things. So protocols do not change. It's only the context where we apply them. Okay? Thank you so much. Thank you so much. So let me go ahead, just to follow up on this real quick. Introduce Dr. Kamal, which is the second speaker for today. As we said, we're going to try to make it as short as possible. If I aim for 15 minutes, I got it. So Dr. Kamal is the program leader for engineering management, has been doing this for quite a bit. So today he's going to be talking about some civil engineering structure safety designs, right?
Actually, our new MOHAMED is going to talk about intelligence and stuff, technology is always advancing. So I knew I'm not going to be able to be compatible with it. The only way I'm going to be compatible with it to make it isn't shaky for everyone. Shaky means riskless. I know not a lot of you might know exactly what the earthquake, what happened during the earthquake. But me, if I had, and Stefano come from a region where the category of that region is considered to be very hazardous in terms of seismic activity. So I'm going to simplify my presentation as much as possible. I know we will have different diagrams, but I'm going to make it as much interesting to remember. Hopefully I will do a good job there as well. So this is a research which I've been working on a long time ago. My last publication was in 2014. I've contributed a lot to the British Code of Practice, and after my contribution to the paper which I published, me and my professor, some provision of Code of Practice has been altered, and now we use them in British design, and I can relate to those provisions as once I go in my presentation. So if we look at the globe, all the red regions are considered to be very hazardous. And if we zoom a little bit more into our region, the United Arab Emirates as well considered to be a seismic active region. As well, if you look at the category, the way they categorize the United Arab Emirates, it has the same category as California. And we know California in 1906 has been swept away. All the city had been destructed by an earthquake. So what happened? The bad news, we might be hit by an earthquake any time. As I told you, UAE is classified like California. That is from the dashboard coming from the government. In the last year, there was 2 earthquakes that struck Dubai at a scale of 5.5. Just to tell you what do we mean by a scale 5.5, when it comes to a scale 6.5, we are looking on destruction. So we are looking at some structure collapse depending on the design of the structure itself. So the good news, there is a lot of code of provision for design to help us have a better safety in our structural design, which they can resist up to 6.5, depending on how much investment you want to pay. The more you pay, the more you are able to build a safer structure. I know you might not be familiar with that. 225 million years ago, that was our Earth. And the Earth is actually moving as we move on until we have now the continent that we know. Now that, which means the movement is going to happen as we speak. That movement is going to happen from now until maybe we never know. Which means some region is always going to be subjected to an earthquake and to movement. The problem in civil engineering, we didn't advance a lot in terms of the material we use. We still use concrete and steel. The only improvement in the material that we use is some fiber material, plastic material, that we started utilizing that to confine to make a better enhancement to our structure. But still, we use the same conventional way in terms of material and somehow in terms of our design itself. That is a very nice clip I got from internet just to show you what happened exactly when an earthquake happened. I hope it runs. If it doesn't run, that's fine. It's not a big deal. That's fine. It's not running, is it? It's not running. It's fine. So that is California in 1906. That is Pakistan in 2005. And we recently had an earthquake in Taiwan in 2016. And the damage was major damages. So what are the solutions? What happened in a real earthquake? Now we know some of the feasible solutions that in Japan they have introduced are to have isolation. What they do is they isolate our structure from the ground. Once you do that isolation, then the ground moves, our structure stay as it is. Such type of technology or such type of design is going to increase the cost of our design by 30%. And if we are talking about a region where we care about cost, we still use conventional way of design. Really, we are not going to pay that extra cost. Most of us are not going to pay that extra cost because developer wouldn't like to pay that extra cost. We are talking about 30 to 40% if we use dampers or base isolation. So what happens in an earthquake, once we have a ground force, if we have an isolation, we can have a reduction in the force factor, the force that go up by 3 to 6 times if we use that base isolation. If we don't use it, if we apply 1 kilonewton there, so it's going to be 6 times at the upper region of our structure, and that can cause a lot of damage. So simply, when it comes to design, we know in any building, the major element in a building is the column and the beam. Column and the beam. Sometimes our column is similar to our beam because of architect design. If the stiffness of the column is similar to the stiffness of the beam, what might happen? A hinge might happen in the column. Once a hinge happens in the column, as if a hinge happened in my foot, which means this is a weak point where it can kill our structure. Directly, we will have a collapse in the structure. So we as designers, we try always to avoid, if an earthquake hit our building, always we try to avoid that the hinge is going to happen in the column. Because the column are the foot of our structure. So just to show you, this is a simulation of a building being subjected to a seismic activity. So I don't know why they're not running.
You're running from
Yeah, that's
Just minimize it.
okay. Maybe that.
Easy. Yeah, now go back to the folder.
Okay. Yeah, we'll run that later on. So once you're seeing that building, once it's shaped, once a hinge happens in the column, directly the building is going to collapse. So what can be done? The alternative, this is an example, similar. That example is similar to the simulation or the experiment that has been done. So the building will collapse directly because of the hinge happening in the column itself. So what we're trying to do, always we're trying to go for a design where the column is stiffer than the beam. So if the column is stiffer than the beam, then always the hinge is going to happen in the beam itself. But that will put a lot of limitation on our side as a civil engineer. Simply sometimes we have to design bigger beams because of the load we want to carry. So it happens sometimes in design, the beam stiffness is equal to the column stiffness. But let me assume we went with design provision and we had the column stiffness higher than the beam stiffness. Still, if an earthquake happens and the damage happens in the beam itself, still the damage can propagate to the top. So even though we're trying to prevent a hinge happening in the column, but still there is a possibility that that crack will go and immigrate to the column itself, and then we have collapse again. So those are simple examples. So what we try as designers, we always try to dissipate energy. Energy dissipation, which means when we have that shaking, we try to dissipate energy as much as possible. Some people put dampers, some people put base isolation, and some people try to change a little bit in the design to have as much as possible to have a ductile behavior, a plastic behavior. If you want to call it a plastic behavior, we call it a plastic behavior. So what we did, well, not we did, usually, that is a very well established theory. Since in concrete we have only concrete and steel, the only way to improve is to try to see some configuration that help in increasing that dissipation, energy dissipation. All of you, when you walk around, you see some circular column. A circular column, usually any frame, any beam, or any column will have three elements. One element we call them the steel in the tension region. Another element, steel in the compression region. So when we put the load, the steel in the tension region will take the load, and the steel in the compression region will take as well some compressive load. And we have a third element, we call them a link between the upper part and the lower part. Why we put those things? Because simply, sometimes our structure might shear off, so we want to put some steel in order to prevent shearing off. So usually a lot of experiments have been done in that domain, showing that if you put a circular shape of link, that can dissipate energy better than having a rectangular shape. Why? For a very simple reason. Because simply a rectangular shape can bulk, can bulk from that side, causing a crack. And then if a crack happens, you cannot dissipate more energy, and you will have a possible failure. Clear? That is a very old theory, which has been tested, verified, a lot of experiments have been done on it. So usually any column around you which has a circular shape, it has the following configuration. Some rebar, some steel rebar, and some spiral links to prevent shearing off. So we said, okay, that's fine. If that can happen for a column, and we know, in fact, it has been very well proven that it can dissipate much higher energy than normal configuration, why don't we use those configurations in a beam behavior? So what we try to do, why don't we put those behavior, because always in a beam we have a rectangular shape or a square shape. We cannot have a beam which is a circular shape. So why don't we try to replicate the same, and we try to see how much improvement we can have when it comes to plastic hinge in the beam. In the column, I'm sure it improved, but we need to see whether we have improvement in the column, in the beam itself. But the problem, the code of provision, the American code, the New Zealand code, the PS code, the British code, all code of practice when it comes to beam configuration that have the following configuration, they are equivalent to that, which means it's as if you are not putting any link, shear link, that can resist any shear force. Why? Because for a very simple theory, because there is a theory called the truss mechanism. I don't know if you need to go into it. It says for that to act well, for that beam to act well, there should be a joint between the force in the tension zone and the force in the compression. And the only way to link those two forces is by having continuous link from the upper part to the lower part. In 2009, I started working on some theoretical model saying, look, those code of provision can be improved. Why? Because I went and I tried to mathematically analyze how the forces are going to vary in those spirals. Anyway, I came up with some simulation saying the code of practice when it comes to designing of a column with spiral link, they have some error if you are going to use that in the beam configuration, and I published that in a paper in 2009 in the Canadian Journal. After which, I started working with some of my colleagues back in the UK, where I graduated from, where we've done some extensive experiments. So I started some of those experiments when I was in UK, and then some of my colleagues who they are following up on the same type of experiment. So all what we're going to try to do in the experiment part is to try to simulate the new configuration that we are trying to propose and the normal configuration that we have in our design. We want to test and see how much energy dissipation we can do. So simply I'm not going to go a lot into detail. I'm going to just to show you a simple example. So this is the configuration that we have here. This is when we test it under certain load to see how much load it can take. The code provision tells us it cannot take more than that much of load. Why? Because for a very simple reason. They consider that beam to be equivalent to that beam. So the code provision tells us it cannot take more than that load, but in our testing experiment, we've seen that the beam was able to take a very extensive amount of load. Then we've done, the experiment has been done with all kinds of configuration, and as you see, the prediction from the code, it says there's no prediction. Our prediction from the theory, it gives somehow reliable prediction on the amount of load it can carry. So then, the most important fact is we want to test those under seismic load. The most important fact is that we need a structure that don't degrade in terms of stiffness when we are hit by an earthquake. So what we did, the same beam structure, we went and we done some cyclic loading on it. After you do a cyclic loading on it, what will happen? A hinge will form in the structure itself. What we care about in that hinge, after a hinge is forming in the beam itself, we care about how much it can take more load. Because as well, when the building is hit by an earthquake, a hinge will form, but still the beam is going to carry our floor and our load. So we need to test whether those structures are still capable of taking extra load. So very simply, just to show you the degradation of a normal design structure, and that is the degradation of our proposed design structure. So you can see our proposal shows that our structure will have a better chance in surviving at a later stage. Same applies for different configuration, and that the better configuration showing that the degradation is much, much better than the normal design configuration. So, as well, this is the simple experiment. So in 2013, I published a paper in the Magazine of Concrete Research, and Dr. Khalid knows that is a journal related to civil engineering and structural engineering in the UK. And after that, some provision and some amendment has been recommended by some researcher to the code of practice that might be a possible viable solution in terms of design. And I've just quoted here the amount of download for that particular paper happening from the RIS system that we have at Warren. So conclusion, yes, we came up maybe with a better design configuration. That is a design configuration which is somehow applicable for any kind of engineer or any kind of foreman who's building a structure, because we know if we go to our back home country, not everybody use a civil engineer and a designer to design his house according to code of provision. So simply maybe by recommending some feasible solution and some easy configuration, maybe that will help us in having a better, safer and safer structure, especially in a developed country. Those are the two aspects, those are the complications in that specific area. I know it's a very specialized area, but this is what I'm good in. I'm a civil engineering at the end. Those are the aspects that happen recently in Taiwan and in Italy, and I'm sure a lot of those buildings are built up to the code of the new code of provision. Did we find a total solution? No, there is no total solution in that, because the total solution will be a very costly solution. From 2014 onward, my research has deviated a little bit. Why? Because I'm supervising some master student in engineering and management. So somehow, some topic that we might be able to collaborate on, me and people who work in simulation, like Stefano, simulation of possible structural failure mechanism and its effect on safety. So we have some safety element here and some management element here, or some design element there. And safety leading indicator in the construction industry in UAE. When we talk about safety leading indicator, there are many factors that can play a major role in safety indicator, from design element, from design perspective to any kind of perspective that is related to the layout, to the fitting, to as you go on. That's all from my side. If you have any question, I'm happy to answer.
Let me close this session. Yeah, definitely. So again, this is officially the end of the first seminar series. Again, the idea is, again, not to go into details, maybe to come on a little bit more, but the idea is to spark interest, and hopefully this will help us all partner together on future projects. Let me close this session now, and today we have at 6:30 a guest from Dubai Trade, so hopefully if you're here, again in the auditorium, to talk about the Innovation Award, right, in the Dubai Trade as well. So if you're around, so make sure please to pass by from 6:30 to 7 only, okay? So that's about it for now. If you have any questions, feel free to email me or email Dr. Kamal. Next Tuesday, not next Tuesday, the first Tuesday of next month, we'll have 2 new speakers, and anybody who's interested, please email me your abstract. I'll be happy to add you to this. This whole thing will be content after now. This will be edited and this will be uploaded, which means everybody will have access to this. So I'll try to put it on YouTube, looking at the copyright issues and so on, but hopefully it will be on the YouTube channel for only the Easter Seminar series, okay? So thank you so much. Thank you.